we introduce deep learning, the concepts, and especially the focus will be on the PyTorch implementation of deep learning. And the class materials, including the lecture note and the PyTorch code, are open source at my GitHub. So you just go to GitHub. I will provide the link here. Okay, you just go to GitHub/Tien-Lung and check this AI lecture note. Okay, I provide my lecture notes here. If you visualize this lecture note inside GitHub, you cannot click the link. So if you want to directly click the link I provided, you have to download my PDF, and then there you can get the link. Also, if you go to my GitHub, check the repositories. Okay, all the lectures will be put here. I will add more lectures later on, so you might constantly come back. And then the PyTorch program associated with these lectures are provided here in the PyTorch Colab repository. And I grabbed a lot of deep learning and machine learning concepts slides from Professor Li Hongyi's lecture from National Taiwan University. I highly recommend you to take a look at his videos. I think he gives one of the best machine learning and deep learning lectures, and especially his PPT is very good. So just click this link and check for Professor Li Hongyi's videos. Let's talk briefly about AI, artificial intelligence, machine learning, and deep learning. Artificial intelligence is a big picture. Actually, it's a dream human has been dreaming about ever since as early as 1950s. It is a dream about the computer could be as intelligent as humans, and the machine learning and the deep learning could be viewed as a subset of artificial intelligence, because we have many ways to make computers as intelligent as humans, but machine learning and deep learning want to find a mathematical equation. So we want to find a mapping, okay, from the given training data and the given label. So machine learning could be seen as a part of artificial intelligence where we have solid mathematical foundation. And deep learning is a part of machine learning in which this mapping function is no longer a mathematical function, whereas this mapping function is an artificial neural network. Okay, so machine learning includes deep learning, and deep learning is a subset of machine learning where this mapping function is a neural network. Of course, just as we said earlier, okay, the traditional programming approach can also achieve machine intelligence, but the idea is human expert or human programmer write rules to instruct the computer what to do. Whereas in machine learning or deep learning, we just give the computer data. Just give the data, and give the output, the label. Okay, for example, give a cat picture and tell it it is a cat. And then we want the machine to find this mapping from the training data. That's the difference between the traditional programming versus machine learning. And there are several machine learning strategies. The first one is we call supervised learning, means we give the computer the training data and its label. For example, give a cat picture, tell it it is a cat. Give a dog picture, tell it it is a dog. That's called supervised learning. And the second set is unsupervised learning, where we only give the computer the data, and then we want to find clusters from the data. Based on the clusters, the computer can learn. And the third category is called reinforcement learning, where the reinforcement learning, the computer interact with a training environment to learn. If you go to my repositories, my GitHub, and if you check this reinforcement learning, for example, mobile robot, and if you check this, and if you check the videos, this demonstrates reinforcement learning. As you can see, the computer, the AI, interact with the environment to learn. After it learns, okay, it can learn some general rules. Okay, here I demonstrate some fancy results. Okay, once the computer learns how to reach the goal while avoid the obstacle, then AI can interact with a very complicated, can generalize to interact with a very complicated environment. That's called reinforcement learning. And before we go to the details of the concept in the PyTorch implementation, we have to mention two things. First is the data visualization. Usually when we do develop an AI model, before we develop the AI model, we want to use some data visualization tools to visualize and explore our data. If you go to my repositories, okay, and go to here in the AI lecture 1.1, I provide some interesting data visualization tools. But since it's not the focus of this course, I will skip it here. And the second thing is prepare your data for machine learning model to learn, like data cleaning, outlier detection, such. I recommend you to check this link to find more details of data preparation. As it's not the focus of this course, I will skip the details. And then before we, okay, the last thing I want to mention is if you want to learn AI, no matter machine learning or deep learning, you have to learn both mathematics, and you have to be able to do Python programming. Python is a very popular language we use to implement AI. Okay, so that's why we call our course Concept and PyTorch Development, because in order to do AI, you have to be good at both mathematics modeling and Python programming. And in this course, the Python development environment, we will use Google's Colab, the cloud platform, to write Python code. For simple case, it's okay, but later on, if you have lots of training data, it's not very convenient to upload a huge training data to Google Colab Cloud. In this case, you have to download Anaconda to your own computer. Anaconda is a common tool we use to develop, to write Python in our own computer. And for the deep learning framework, usually if you don't want to write the matrix operation or the optimization by yourself, usually we use a deep learning framework. In this course, we will use the PyTorch deep learning framework from Facebook. Of course, there's another popular deep learning framework from Google. Maybe you have already heard it. It's called TensorFlow and Keras. But for academic research purpose, I think 90% of all the academic universities in the world we use PyTorch because it's easier to study the details of the neural network. But since TensorFlow comes to the market earlier, so you might see a lot of industrial applications are implemented using TensorFlow. Okay, that's for the first lecture. Now let's go to the second lecture, regression. Okay, just as we mentioned earlier, for machine learning, okay, we actually learn a mathematic mapping from the training data to the label. So if the label we learn, the y we learn is continuous, this problem is called regression. If the label learned is categorical, then this problem is called classification. So for machine learning or deep learning, actually we just perform two tasks, either regression or classification. And throughout this course, I will use these notations throughout this course. These notations I follow from Li Hongyi, Professor Li Hongyi's lecture. So I will use superscript to represent data. So if I put x9, superscript means the ninth data. And the subscript means the features. Okay, so for example, this data contain 19 features. Okay, so this is x subscript 1, the first feature, the second features. And then I will use y hat to represent the true answer provided by the user. And just like we said, machine learning has a solid mathematical foundation. So how, in the machine learning context, how the machine learning learns? Okay, first we need to define a mapping function. We need to define this function. Then we need to define a loss function to measure how far, what's the distance between the answer predicted by our model and the true answer provided by the user. And then we want to find the optimal parameters that can minimize this loss function. When this loss function is minimized, means yn is equal to or very close to the y hat. That means the answer predicted by this model, this mapping function, is close to the true answer. This is how the computer learns. So there's no magic behind. Okay, if you want the computer to learn, you have to define a mapping function. Then you need to define a loss function. Then you have to minimize the loss function. The 3 steps. And if you take some statistics course, maybe you already know the linear regression. The linear regression is a special case of the machine learning where the model is a linear combination of the features. Okay, so the model is a linear combination of these features. And the loss function just measure the square of the distance because sometimes the true answer may be larger than the predicted answer, and sometimes the true answer may be smaller too. So we use the square of the distance to measure the loss function. And for linear regression, we can solve this loss function, minimize this loss function by closed form. But if this loss function is nonlinear, then it's difficult to solve. Usually, we will use gradient descent to find the optimal parameters. So taking a simple example, okay, just like I say, I took a lot of slides from Li Hongyi's machine learning lecture to explain the deep learning concept. Okay, suppose, okay, we want to minimize a loss function that has only one parameter, w. Suppose w0, we randomly guess a value w0, and then we calculate the slope here. Okay, if the slope is negative, like this, then we know we just increase w. We have to increase w to make the loss function become smaller. If the slope is positive, like here, if our w0 is here, then we know we have to decrease w to decrease the loss function. So the idea is we have to, if the slope is negative, we have to increase. That's why we put a minus sign here. And if the slope is positive, then we have to decrease. So we put a minus sign here. That's why we call descent. Here we do slope descent. We will explain what is gradient. Okay, so first we do descent, and then we decrease along the slope direction by a factor. I will not go to the details of gradient descent. You might take a look at Li Hongyi's lecture, but theoretically, if we go along the slope or gradient direction with a very small amount, we are guaranteed to find the local minima. So this eta is called the learning rate. So we go along the minus direction of the slope with a eta small ratio, then we are guaranteed we can find the optimized solution to minimize this loss function. And if we have more than one parameters in our loss function, then we just do partial derivative. And if we take the loss function versus all the partial derivative versus all the parameters, then this vector formed by the slope, the partial derivative along each parameter is called a gradient. That's why we call this method gradient descent, because we descent, we minus the gradient along the gradient direction. And if we use a neural network as the mapping function, then this machine learning is called deep learning. So deep learning is a subset of machine learning, whereas this mapping function is a neural network. And if we use a neural network to represent the mapping function, then the details of the neural network we will explain later. Here we just give a brief introduction of the neural network. So it is a fully connected and forward direction, means at the second layer, okay, the result is the linear combination of all the previous result times a weight plus a bias, and then takes an activation function. The meaning of this activation function we will explain later in our later lecture note. Okay, and similarly, the next layer is a linear combination of the value of previous layer times a weight plus a bias function. And then similarly we use gradient descent to find the optimal parameters of this weight. Suppose here should be loss, okay. Suppose we have a loss function and we want to know how much we should adjust these two weights to make the loss function smaller. Then we know we should go along we should minus the partial derivative along. That's called descent, gradient descent with a small learning rate eta. And we know by chain rule from calculus, the partial derivative of this loss function versus this weight is the partial derivative of this loss function versus y. And because because this loss function is a linear combination plus a activation function, so this partial derivative can be calculated, and the w is a function, and y1 is a function of w. Okay, so by using the chain rule from calculus, we can calculate this. Similarly, using chain rule, we can calculate the weight, the partial derivative here. And similarly for the next layer, if we want to calculate how much this W57 should be adjusted to decrease the total loss, then by using chain rule, if we want to get the partial derivative of the loss function versus this weight, then first we take partial derivative versus y1 and partial derivative y1 versus n7. n7 is a function of this W57, and then take partial derivative n7. Okay, this is called backpropagation. Of course, we will talk the details of this backpropagation in our later lecture notes. When we talk about deep learning, if you want to know more about deep learning, Google search Geoffrey Hinton. He is the father of deep learning. He has always been thinking how to use neural network to let the computer has intelligence rather than writing rules to instruct the computer. Instead, we just define a neural network and let the computer learn from the data. Okay, so if you want to know more, Google search Geoffrey Hinton. Okay, now with this, let's take a look at how to implement a regression model using deep neural network. So as we mentioned in this course, we will use Google's Colab environment. So you just open and search for Google Colab. Click it, and then you have to log in using your Google account. Once you log in your Google account, check this GitHub tab, and then search for my GitHub, which is Tien-Lung, TLS in capital. Search for my GitHub. And as I mentioned, I put all my PyTorch code associated with this AI lecture in this folder 2020 PyTorch Colab. So you just open the MLP regression. Okay, let's take a look at this PyTorch code. The first cell or the first line, just import the PyTorch framework. As I mentioned, in this course, we will use the PyTorch deep learning framework. So you can click here to run. When you run, it will warn you, okay, you are running, this notebook is not created by Google, is loaded by you from GitHub. You want to continue, just say continue. Okay, so now we import the PyTorch deep learning framework to our Python program. And then now it's connected. And then the second cell check whether we have GPU or CPU. Okay, for deep learning, as we will see later, actually we are performing matrix operation, and this matrix operation can be parallelly computed to speed up the speed if we run this neural network on GPU. Fortunately, Google is very generous. Even if you use its free cloud platform, Google still provide you the GPU. So you just go to this execution stage and change execution type, and then you can select GPU. Because here I already select GPU, so I just cancel. As you can see here, Google provides me with a Tesla T4 GPU for me to use. You can Google and check. I think this GPU costs $300 US. And then we just generate a set of training data for us to train. We generate a set of training data. Here I want to generate 100. I use a for loop to generate 100 data. I go from minus 5,000 to 5,000 with step 100. Okay, just like I said, we use the Python programming language to develop AI. So if you want to know more AI, you better study Python programming. Okay, here I use a for loop to generate data. And then I let y become 3x squared plus 25x cubic function to generate y. So in this case, I generate a very simple training data set. I have 100 data, but for the features, I only have one features, and this y is a quadratic equation of x. So I just run it to generate my data. And then I convert my data, because here I generate my data using a list and store it in a list. And here I convert my data from list to array. And I import the NumPy. Okay, so list is a very common, very useful data structure in Python. If you are interested, you search Python list to study more. And NumPy is a Python module to handle the linear algebra. Okay, why Python becomes so popular recently? Because it provides a lot of free open sources for you to use. Actually, no matter what task you want to do, from linear algebra to statistics to machine learning to deep learning to whatever you want to do, you can always find free Python modules for you to use. And to use these Python modules, you just import. And here I give it a nickname, means later on I don't need to type NumPy, I just type NP to represent NumPy. So here I call NP array function to convert the list data structure to array. And as you can see here, our array contains 100 rows and 1 columns. Okay, and then I call another useful module called sklearn in Python. sklearn is a Python module for you to do machine learning, and I split my data to training data and test data. I put 80% as the training data, 20% as the test data. Okay, and as I mentioned earlier, I will use white hat to represent the true answer. So I use the white hat to represent the true answer. Here I call another important module in Python called matplot library to show, to draw, to visualize this data. So the training data is shown in blue and the test data is shown. So I randomly split my data in 80% as the training data and 20% as the test data. Now I start to build my neural network. You can click here to run, or you type Shift Enter to run. And then here I build a neural network that contains the input contains one node because my data has only one features. So the input in this picture here, the input data contains two features, but here because my data has only one feature, so I build the input 1. And 30 means the second layer, the hidden layer, contains 30 nodes. And then I apply a ReLU activation function to this neural network. We will talk about the activation function later. Here you just need to know I apply a ReLU function to. Okay, and then the second layer contains 15 nodes. And finally, these 15 nodes connect to one node because we want to output the value of y. So I define a neural network, and then I send this neural network to the GPU, okay, in order to do the matrix operation in parallel. I just run this, and as you can see here, I print my neural network structure. As you can see here, it takes a while. Okay, the input feature is one node, output is 30 nodes, and 30 nodes to 15 nodes, and then to one node again. And I define my loss function. Okay, just as for machine learning, you have 3 steps. First, you define a mapping function, and in this case, it is a neural network. And then you define a loss function to measure what is the difference between the answer predicted by the model and the true answer. And the loss function we use is mean square error, means we take the difference between the true answer and the model predicted, and the answer predicted by the model, we take the square, and then we take the mean. In this case, we have 100 data, so we take the square of the difference of this each data and divide it by 100. That's mean square error. And then finally, we need to perform optimization to find the best parameters. We need to find the best parameters of our neural network. And here we define how to perform the gradient descent. For this moment, you don't need to worry about this atom. At this moment, we will explain this gradient descent method later. And this learning rate, we just explained when you go along the gradient direction, how much you should go. As we mentioned earlier, theoretically, this learning rate should be as small as possible. But if your learning rate is too small, then your learning process will be slow, because each time you move along the gradient direction by a very small step. So I define the optimization. So these are the 3 training steps, and it applies to any machine learning any machine learning framework. Okay, so just like machine learning is a subset of artificial intelligence, where we have a solid mathematical definition. Okay, so these 3 steps: define the mapping, define the loss function, define the gradient descent strategy to find the optimized solution. Now, let's send our input to the neural network and calculate the loss function and perform one-step optimization. Just means we calculate the gradient and move along the gradient one step. Before we send our training data to the neural network, we have to convert the array representation to tensor. Tensor is an array representation that can be performed in GPU to do parity. So here I convert this array. I convert this array representation to tensor and send it to GPU. And then I send my tensor representation to my neural network to calculate the predicted value, and then calculate the loss function, the mean square error between the value calculated by our neural network and the true answer, y hat. And then I perform one step along the gradient direction to adjust the weight. So now, as you can see, the loss function is large because our neural network haven't learned yet. So here I use a for loop to let my neuron to perform 2000 optimized gradient descent. So every time we calculate the gradient, move along the descent along the minus gradient direction with a learning rate, and then we perform 20 times. And I use a list to record the loss, calculate. Now I just take a look at this loss function. So as you can see, the loss function gradually go from 1 to the power 15 gradually to become 0. Okay, after like 1000 epochs. Okay, means it moves along this gradient direction 1000 times, and we can reduce the loss function to close to 0. Now let's test our model neural network using the test data. The test data is never seen by the neural network. So okay, as you can see, the loss is still large, but let's take a look. Okay, here what I did is convert, because this y is calculated by the neural network, so it's in GPU. I just detach it from GPU and convert to CPU to NumPy, because I want to use matplot to visualize it. So I have to convert from tensor GPU back to array in CPU, and then just see. So the red line is the true answer, is the y hat, the true answer. The green dot is the answer predicted by our neural network. So if you can further improve the performance by training it more times, for example, for another. Okay, that's how to use the neural network to do regression. And if you want to know, okay, suppose my data is in a data file in Excel. How can I read data from Excel? Here, I provide an example to show you how to read data from Excel. So you just open a new, go to GitHub, go to PyTorch Colab. Here, if you open this read Excel data file, it will ask you whether you want to leave the previous code. I just say yes, leave, and then load the new file. Okay, here is the same, import torch. It warns you, okay, continue. And check for GPU. Yes, we have GPU. Now, I already prepare an Excel file. Okay, you can take a look. It's in the same directory here. It's called MLP regression data. So what you did, okay, you can download it. Here, what I did, I let x go from -5,000 to 5,000 as we did in previous program. If you here notice that I used the formula, okay, to generate this data, and similarly y is equal to 3. Y is equal to 3x squared plus 25x plus 580. Similarly, I use formula to create this data. So this data is created in Excel, and you can download from my GitHub. Once you download to your local computer, you can just upload to the cloud. Google, just select. I just download it. And here, I just check, because this upload function will allow the user to upload multiple files. So I just use a list to store these multiple files, and then I just get the first of these files. Okay, in Python, the index starts from 0. So here, okay, so make sure we read the data to Python. And then we use another important module called Pandas. Pandas is another important Python module for us to read, to do data analysis. So we just import Pandas and use the read Excel function from Pandas to read this file. Okay, once we read this file, the data, if we read from Pandas, is called data frame. The data structure is called data frame. We use this data frame to see, for example, the header, the first of 5. I think if you type tail, then you can take a look at the last 5. And then we take a look at the column. And then we did the same thing. First, we extract the X column. We extract the X column of this data frame and this Y column of this data frame, and then convert to NumPy. And then split, and since the remainings are the same, I just skip it. Okay, so now we have already learned how to use PyTorch to create a neural network, and later learn a regression model. And we run this PyTorch in Google Colab. Okay, now let's take a break here. Now, And then when we start, we will teach how to debug this learning process, because we are dealing with simple data. If you are dealing with real world data, it's impossible to get to train the neural networks successfully at the first try. So we have to know how to debug this training process. Okay, let's take a break here.